Hey everyone, welcome back. So in this video, we are going to see the third questions, right? We have already seen the Q1 and Q2. This is Q3 and the contest is off. Okay. So the question we have given is minimum time for K connected components. Okay. So let's understand the question here. So let's read the question, what the question is saying. Okay. The question is saying you are given an integer n, right? And you are also given a undirected graph, that is we have n nodes we have given, okay, from 0 to n minus 1. So this is represented by a 2D graph, a 2D array, that is edges, right? And where edges at I is u and v and time. It indicates an undirected is between u and v that can be removed at time t. You are also given integer k. So initially the graph may be connected or disconnected, and your task is to find the minimum time t such that after removing all the a's with time less than equal to t, the graph contains at least k connected components, and we have to return the minimum time. Okay, so what is a connected component? Connected component is a subgraph of a graph in which there exists a path between any two vertices and no vertices of the subgraph shared an edge with an vertex outside of the graph. Okay, so this is the statement we have given in the problem statement. Okay, now understand what the question is saying. Okay, I hope you understand till now what the question is saying, but if you are still not understanding the question, don't worry, I'll break down the problem in very simple steps and we'll go through to understand in very deeply. Okay, so what's the problem is saying? The problem is saying that you are given two things, right? The very first we have given n is 2. As you can see in the example here, n is equal to 2 means n is the n nodes, right? That is level from what? 0 to n minus 1 means n nodes we have given very first, and then we have given what? Graph level that 0 to n minus, okay, and edges, yeah, edges. So next we have given edges, right? So these edges we can say there's some edges we have given. Let's suppose we can say where edge at two nodes is u and v, and there is time t. U, v and t, three things we have given at each edge, right? So as we can represent, this edge is 0, 1 and 3, right? We have given in an array. So if we'll represent this array, it will look like this one, right? So this is 2D array, right? Edges are 2D array, but at each index we have a 1D array, right? Where index at 0 is u, means one node, index at 1 we have another node, and there is index at 2 we have time, u, v and time, each edge contains, and we have given k, that is our a target number k, we can say that, correct? So if we'll represent these two nodes, that is u and v, and this is t, right? How will you map it? It will become 0, 1, this is u and this is v, and we can connect it, right? And so the time between this is 3. Meaning of an edge is what? An edge, each edge connects two nodes, u and v, two nodes it's connect, right? And has a removal time also given. This is the removal time. So at time t, that is 3, you remove all the edges whose time is less than 3, right? Understand? At the time t, you remove all the edges whose time is less than equal to t. Okay, I hope you understand, right? So what is the goal? We have to find the minimum time. So minimum time is what? Minimum time, so after removing all the edges with time t less than equal to t, the number of connected component in the graph is at least k. At least k. The number of connected components in the graph is at least k, right? Now understand what is connected component, right? What is a connected component? Connected component, can we say that? What is connected component? Think. So connected component is a group of nodes, you can say, right, where each node can reach any other node in the group directly or indirectly, right? And no node in that group connects to the node outside of the graph. Okay, let's suppose we have 0 and 1. So these two nodes we have given, right? So each node means node this and node this, right, can reach any other nodes. Okay, it can reach any other node, means only two node is there, it can reach either directly or indirectly. Let's suppose there is one more node is there, so it is connected, right? It is connected, it can directly go or it can go like this. So this is called connected components, right? Directly or indirectly, right? Either this is not there or it is there, it is not there, it is there. This concept is called each node can reach any other nodes in the group directly or indirectly. So this will treat as, we can treat it as a group, and so this group of nodes is called connected components. I hope you understand, right? There is no node in this group that connects to the node outside of the group. It will, if any other nodes are there here, let's suppose, right, it will not connect directly. Okay, that is called connected components. I hope you understand, right? For example, now understand, we'll take this example. Okay, so we have given n, we have given 2, k we have given 2, and the edges we have given is what? Let's suppose is we have given 0, 1, 3. This is just a array. Can we say that? This is the thing we have given, right? There are two nodes, that is 0 and 1. How many nodes are there? Two nodes. So there is one edge between 0 and 1, right? If we represent, we are representing like this. Can we say that? 0 and 1, right? And there is time is 3. And we have been asked, right, what is the time, what is the minimum time? What is the minimum time such that after removing all the s with time less than equal to t, right? What is the time, minimum time? T. What is the minimum time? T. See here, what is the minimum time? T, right? So that after removing all the edges, let's suppose if I'll remove this edge, so time, if it is less than equal to t, that we have to return. So there should be at least two components should be there, right? There should be at least two components. So let's try the value of t. What are the value of the t? Think. When t is 0, then no edge is removed, right? Because if you will remove here, so the graph is what? 0 and 1, right? There is only one component is there, we cannot remove, right? When t is 0, we cannot remove because there is only one edge. Now similarly, let's call this time 3, so we can remove the edge. Why? Because there is 0 and 1, means that is isolated and there is two components there, right? And so it is also saying that time is equal, right? So we can say answer will come 3, and you can see answer is coming 3. I hope you understand, right? So what is our intuition? Our intuition, so let's think that if you have, let's suppose if you have remove more than edges, if you remove more edges, right, multiple edges there, the graph becomes more disconnected, right? If there is multiple nodes are there like this, think. Let's suppose you remove this one, right? So the new graph will become like how? Like this. It means if you remove the edges, you have removed these edges, right? And so it is become what? Disconnected. This become disconnected, right? It is still all are connected, but still if you remove this one now, let's suppose, so what is the left is there? These two are connected, but this is not connected, right? So it is getting disconnected. If you remove more edges, means the graph becomes more disconnected, right? So at some point, the number of connected components becomes what? Greater than equal to k. So the number of, we can say, connected components is greater than equal to k, right? So at some point, let's suppose at t, okay, so you want to find the minimum time when this is possible, right? You want to find the minimum time when this will happen, right? I hope you understand, right? Let's understand through an example. Let's take an example, little bit will take, so let's call it a 5n, and k will take this time 3. Then we can take edges is, let's call it let's suppose we'll take 0, 1 and 2. Then we can take what? 1, 2 and 4. Then we can take let's say 2, 3 and 6. Then we can 3, 4 and 8. Can we say that? So this is our edges. If we'll represent this, how we are going to represent this? Let's suppose if I will represent this 0, 0 will go to 1, right? 0, 1, and there is 1, 2. We can say there is 2 is also there, right? 2 to 3, 2 to 3. Let's call 3 and 3 to 4. Can we say that? Till that. Now from 0 to 1, this is just, you can take in a straight line also, right? We can say that. So from 0 to 1, what is we have? 2 we have. So we'll say 2. 1 to 2 is 4. 2 to 1 is, 2 to 3 is 6. And similarly we have 8. So these are the times we have given, right? These are the times we have given, and these are the nodes we have given. Each nodes we have given, right? Each nodes are connected. Can we say that? So if we will represent this as, the graph will look like this, right? Means each edge connects 2 nodes, right? That we have given at here. So each edge has a removal time that I am representing in the red color. And our goal is to find the minimum time such that after removing all the edges with time less than equal to what? Time should be less than equal to t, right? And so the graph has at least 3 components, right? How many? At least 3 components. Can we say that? So now what we can do, give me 1 second. Okay. Now think, we are trying to remove t at 0. So t at 0, we cannot remove any edges because this is fully connected. As you can see, this is fully connected. So the connected component is what? Total number of connected component is what? 1. Total number of connected component is 1. So we cannot do anything. So we will not remove anything, right? Okay. No edge removed. No edge removed. Can we say that? When t equal to 0 means we cannot remove anything. Now k equal to 3. So let's take directly t equal to 3. So we have to remove the edges with time. This is time, and it should be less than equal to what? 3. So only remove what? Only remove G. We can remove, think what we can remove. Which one is smaller one? So only one is a smaller, this one. See the time, 2. So we can remove this one. So from 0 to 1, we will remove this part, we will remove. Correct? Can we say that? So the removed edge is 0 and 1. What is the remaining one? These are the remaining one. These are the remaining one. So remaining one, we can say but we have removed this part, but we have what remaining edge we have left is 4, 6 and 8 because it was connected. We have removed the edge 0 and 1, right? I think I have shown you little. We should not like right like that. Let's suppose we are removing this one. Okay, so the remaining is what? Remaining is from here to here. We are removing edges, right? We are removing edges. So now if you check 1, 2, 3 and 4 are the nodes having edge 4, 6 and 8 times, right? So total graph, it will become what? If we will represent this, we can say graph become what? The 0, not here. Give me 1 second. Let me clean this, okay? Okay. Sorry, I'm taking more little time. Okay, so what is the final graph now from here? We'll take graph 0, there is no edge, so we'll leave it. Then we have 1, we have 2, then we have 3, then we have 4. Can we say that? So these are the nodes that are connected. So this is our final graph, right? So still it is connected from 1 to 4, but 0 is isolated. It is isolated and these are connected. Can we say that? So the connected components is how many? Connected components here, CC is not equal to 2. Can we say that? This time let's try t equal to 5. Can we say that? Let's try. So I have cleaned this. Okay, so let's understand. So when t equal to 5 will take, means we have to remove the s with time less than equal to what? 5, correct? So what are the times we have left here? So if we'll mark it from 1 to 4, 1 to this is 4, this is 6 and this is 8. So we have taken this one. So this time if we'll remove this, which one we will remove? We can remove what? This one, right? So we have removed one is now, if we'll 0 was there, right? Here now the removed is 0, 1 and 2. These are removed, correct? And 1, 2 and 4, because we can remove this one, right? So this is now isolated and these are connected. Isolated and connected. Can we say that? We can say that. So the remaining become what? So the, let me write here. Okay, so the removed is 0, 1 we have removed and 1, 2 we have removed. So remaining is 2, 3 and 4 now. Can we say that this is our connected one? So the graph left is, final graph will become at this one is this is your 0, it is isolated, this is your 1. So both are isolated. These are isolated and these are connected. So the number of components is how many? Components are 0, 1. These are different, right? This is different. This is, both are independent, right? This is isolated, this is isolated. So we can say 0, 1, 2, 3, 4. So total number of component is here. CC is what? How many? 3. So it is right. It is good. Previously it was coming 2, right? Now it is coming how many? 3. So this, see here, total 1 component, 2 component and 3 component. It was previously it was these 2. So now number of component is equal to 3. So we can say if it is equal to 3 means return the number of component, the minimum time, right? So the minimum time is this time when t is equal to 5, means this time when t is the minimum time t equal to 5 is the first time when we get the number of minimum component 3 greater than equal to 3. Okay, and so we'll say our answer is 5. I hope you understand. Still, if you have doubt, please ping me in the comment box. Now understand the code. Okay, let me zoom a little bit. Okay, so the very first, what you need to do, let me zoom a little more. Okay, so the very first, what you need to do, we have given three things. We have given n, s and k. No need to explain much. Just think that very first step is to sort the s by time, right? We will sort all the s's based on time, right? So there is a concept of comparator, right? In Java we will use comparator and we'll sort this, right? So this will make it easier to process s's in order of increasing time later during binary search, right? Because see, the intuition, we have understand what we need to do, and the approach we are going to use is binary search, right? And why we are going to do the binary search? Because the edges we have given and we don't know it is sorted based on the time or not, right? So to based on the time, we have to sort the edges by time like this. So this is the array.sort method, right? But if you want to sort based on our own implementation, so we'll use comparator, right? And this comparator we have to pass comparator dot comparing int, and you will pass where at 2, 0, 1 and 2. 0 we have u, at 1 we have v, and at 2 we have time. So this is our time. So based on the time we will sort it. I hope you understand, right? So what it will do, it will make it easier to process the edges in order of increasing time later during the binary search. Then for the binary search, you know the template of binary search will have low and high, right? And initially we'll take answer as -1. If we'll not have that enough things, right, we'll return -1. So for the binary search we have low and high, right? So we'll keep checking low and high, right? If low is less than equal to high, we'll do the binary search. You know how to find the mid. We'll do low plus high minus low by 2, and we'll check if component after removing, right, it will give the number of components, right? Because at each time, right, we are checking the number of components. Like previously we have removed, it was number of component 0, then become 2, then 3. As become equal to 3, equal to greater than equal to k, means this is our search. Get the answer, set the mid equal to answer, and update our smaller time, check the smaller time. Otherwise we'll update our low and we'll find our answer, right? Means what we are doing here, we are doing binary search over time, right? From 0 to 10 to the power 9, we can say that, right? 10 to the power 9. You count the number 0, you will get 10 to the power 9. Okay, so at each time, in each step, you can say, right, we'll try mid time. This is our mid time, and we'll remove all the edges with the time less than equal to mid, right? If we will find the what we call less than mid, right, means we will remove. Okay, we'll keep doing that, and when then we will check how many connected components are left, right? And if the components is greater than equal to k, we'll try the smaller one. Okay, else we'll try the larger t. Okay, and so we'll keep checking the value. Okay, so this is our connected, we will get the connected component after removing, right? So for that, what you need to do, we will create the first of all the disjoint set union, means we will use a union find data structure. So in the second topic, right, I've already explained what are the things are there, right? In the question number 2 we have to explain, right? So we'll create here disjoint union set, DSU you can say, or union find data structure you can say, and for every edge we'll go iterate, and we'll for every edge not remove if time is greater than t, right? We do union of the two nodes, right? After that we'll ask DSU to connect, right? This one, if t is greater than, if time is greater than t, means we'll keep checking every is not remove. When time is greater than this, of that we will do union, right? We will merge them. After that, how many components are left, will return it. Okay, and you know the template of union find, right? Union find data structure contains parent, rank, components, and this is the union find, and this is the number of components initially, right? After the find, you will find the parent, and to merge, this is our merge, and when we will merge, number of component will do minus minus, and this is the method to return the number of components. Okay, I hope you understands, right? So these methods that we call find, union, right? So find will return the parent component of a given x node, right? And u and v union will take merge the component of x and y, and components, get components will return the component counts, how many separate group exist, right? And finally we'll return your answer, right? This is the smallest time we can say, such that after removing edges where time is less than equal to t, we have at least k components that we will return. Okay, still if you have any doubt guys, please let me know in the comment section, and if you want any help, don't hesitate, right? Just write the time complexity, what is the efficiency we have in this approach, right? I'll give you this hint. Binary search will take log of 10 to the power 9, so it will come approximately what, 30, right? And we'll each time we'll check union find over the 10 to the power 5 edges, right? Nearly it becomes what, you will know that is linear, right? And the total time is accepted by the constant that we have given. Okay, so I hope you understands. Still if you have doubt, please don't forget to comment the video and like and share with your friends, and keep supporting Expert Funda by like and subscribe. Thank you. I'll see you in the next one.